Namaste everyone. Welcome to 6th lecture of Introduction to Trigonometry. This is Rajesh. In this lecture we are going to see trigonometric identities and solve exercise 8.4. Now let us first understand what we mean by identities. An equation is called an identity when it is true for all values of variables. For example, a plus b the whole square is equals to a square plus 2ab plus b square. Now here you take any value for a and b on left hand side, put the same value on right hand side, you will get that your left hand side and right hand side are equal. So your left hand side and right hand side for this equation are equal for all values of a and b, hence this a plus b the whole square is equals to a square plus 2ab plus b square is considered as identity. In the same way, an equation involving trigonometric ratios of angle called a trigonometric identity if it is true for all values of angles involved. Let us understand with one derivation. Here you can see triangle ABC. In this triangle ABC, angle B is 90 degree. So AB square plus BC square is equals to AC square. Now we will divide both the sides by AC square. So when I divide both the sides by AC square, we get AB square upon AC square plus BC square upon AC square is equals to AC square upon AC square. This I can also write as AB upon AC the whole square plus BC upon AC the whole square is equals to AC upon AC the whole square, or I can write 1. Now AB upon AC, if you see in the diagram, this is AB and this is AC, and if I try to relate this AB upon AC with this angle theta, so I will get that this AB upon AC is nothing but sin theta. So this AB upon AC square will be sin square theta. And the same way this BC upon AC, this ratio is also related with theta, and we can call this as cos theta. So this is sin theta the whole square, this is cos theta the whole square. Now sin theta the whole square I can write as sin square theta, and cos theta the whole square is written as cos square theta. So sin square theta plus cos square theta is equals to 1. Now here I have taken theta any general angle. So as this equation is true for any general value of theta, I will call this sin square theta plus cos square theta is equals to 1 as a trigonometric identity. So sin square theta plus cos square theta equal to 1 is one of my trigonometric identities. Now this sin square theta plus cos square theta equal to 1 you can write in some other formats also, like you can say that cos square theta is 1 minus sin square theta, sin square theta is 1 minus cos square theta. They are all different forms of this identity sin square theta plus cos square theta equal to 1. Now in the same way, if I divide this equation 1, which is AB square plus BC square is equals to AC square, by AB square, then I will get one more identity which is 1 plus cot square theta equal to cosec square theta. And if I divide equation 1 by BC square, I will get 1 plus tan square theta equal to sec square theta. Now this identity 1 plus cot square theta is cosec square theta can also be written as cosec square theta minus cot square theta equal to 1, and 1 plus tan square theta equal to sec square theta can be written as sec square theta minus tan square theta equal to 1. So these are three identities. One is sin square theta plus cos square theta equal to 1, one is 1 plus cot square theta equal to cosec square theta, and 1 plus tan square theta equal to sec square theta. These three identities are very important. You will definitely get some problems based on these identities. Now let us see exercise 8.4. First question is, we have to express the trigonometric ratios of sin A, sec A and tan A in terms of cot A. Right? So just now we have seen three identities. Now these identities are, you can say that they are relations between trigonometric ratios for a given angle. So sin square theta plus cos square theta, is equals to 1. This gives me a relation between sine A and cos A, right? So here, as I have to express this sine A, sec A and tan A in terms of cot A, that means I have to express sine, sec, tan in terms of cot. That means I have to find the relation between sine A and cot A, sec A and cot A, and tan A and cot A. So better, as I know identities, I will use. So for cot A, I have one identity, that is 1 plus cot square A is equals to cosec square A. Now here I need sine A, so I convert this cosec square A in terms of sine square A, which is 1 upon sine square A. So 1 plus cot square A is equals to 1 upon sine square A. Now I need sine square A, so it is 1 upon 1 plus cot square A. I take roots on both the sides and I get sine A as square root of 1 upon 1 plus cot square A. So here I have to express sine A in terms of cot A. This is my first expression. Sine A equal to root of 1 upon 1 plus cot square A. Now tan A is 1 upon cot A. We already know that tan and cot, they are reciprocal of each other. So tan A is equals to 1 upon cot A. So I got this second relation also. Now this sec A I have to express in terms of cot A. So for that I use one identity, which is 1 plus tan square A equal to sec square A. Now I have the value of tan A in terms of cot A. So I will replace this tan A in terms of cot. First I will write sec A as root of 1 plus tan square A. Then I put the value of tan square A, which is 1 upon cot square A. So sec A is equals to square root of 1 plus 1 upon cot square A. Now I cross multiply and I will get cot square A plus 1 whole divided by cot square A. So this is sec A. Sec A is square root of cot square A plus 1 upon cot square A. Now this denominator, which is cot square A, is in square root, so I can move it out. So finally I will get sec A as root of cot square A plus 1 upon cot A. So I have three expressions. One is sine A is equals to root of 1 upon 1 plus cot square A. Second, I have tan A equal to 1 upon cot A. And third is sec A is equals to root of cot square A plus 1 upon cot A. These three equations are the required expressions of sine, sec and tan in terms of cot. Let us move to second question. I have to write other trigonometric ratios of angle A in terms of sec A. So I have to express all the angles in terms of sec A. So there are total 6 ratios. One sec A is already given. So I have to express other 5 ratios in terms of this sec A. So let us begin. Again, sec A, related with sec A, I have an identity 1 plus tan square A is equals to sec square A. I will start from here. So from this I will get tan square A is equals to sec square A minus 1. And this gives me tan A as root of sec square A minus 1. Now cos A is 1 upon sec A. So I got this second relation. Third, I know that tan A is sin A upon cos A. So as I have value of tan A and I have value of cos A, I can find value of sin A as tan A into cos A. Let us put the respective values. So tan A is root of sec square A minus 1 into 1 upon sec A, the value of cos A. So I will have sin A is equals to root of sec square A minus 1 upon sec A, right? So once I have sin, cos and tan, I can easily find the other three ratios. So cot A is 1 upon tan A. Value of tan A is root of sec square A minus 1. So cot A is 1 upon root of sec square A minus 1. Cosec A is 1 upon sin A. So sin A I got as root of sec square A minus 1 upon sec A. So cosec A will become sec A upon root of sec square A minus 1. And sec A is already given. So these 5 equations are the required expression. There are other ways also by which we can find out the relations, but I recommend that in 10th standard, as we are studying identities and under identity topic we are having this exercise, so it is better that we solve all the problems using identity. Now third question is evaluate sin square 63 plus sin square 27 upon cos square 17 upon cos square 73. I have to find these values. Now in the previous lecture I have told you that whenever angles are other than 0 degree, 30 degree, 45 degree, 60 degree and 90 degree, you all use complementary angle relations. But here, as square terms are involved, and just now we have seen trigonometric identities, so it is better that you try to solve this with trigonometric identities. Here if you try to apply that complementary relations, okay, you will not arrive at final answer until you are also apply trigonometric identities. So sine square 63 and this is sine square 27. We know that sine square theta plus cos square theta is 1. So better I convert this sine square 27 and cos square using complementary angle relation. Similarly here cos square 17 plus cos square 73, here also I will do the same way. So here what we do, we convert this sine square 63 and this sine square in terms of cos square, and in denominator it is cos square 17 plus this is 60 sine square 90 minus 73. So finally I will get sine square 63 plus cos square 63 upon cos square 17 plus sine square 17, that gives me answer 1. Okay, if you convert all the sign in cos, right, if we try to apply the complementary angle relation, so this sine square 63 I can write as cos square 17 and that sine square 27 I will write as cos square 73. So numerator and denominator both are same, so I will cancel them and I will get answer as 1. So here you can use both the ways. Either purely apply complementary angle relation, there is no need to apply this trigonometric identity. Second question, sin 25 cos 65 plus cos 25 sin 65. Now here as it is plus sign, if I purely apply complementary relation and convert everything in terms of cos or everything in terms of sine, then they are not going to cancel each other and I will get some value in terms of sine or cos only, right? So that will not help me out. So better I will try to use identity. So this is a sine, this is cos. This cos can be converted in sine using complementary angle relation. So I have sine 25 and to this cos I will convert in sine. So I get sine 90 minus 65 plus this is cos 25 and this sine 65 I will convert in cos 90 minus 65. So all the angles are 25 degree. I have used complementary angle relation. So here you have sin square 25 and here you have cos square 25. Now sin square theta plus cos square theta is 1. So therefore I will say this my answer of sin 25 cos 65 plus cos 25 sin 65 is 1. Now fourth question, it is options given. I have to choose correct option. So 9 sec square a minus 9 tan square a is equals to. So here if I take 9 common, I will get sec square a minus tan square a, and I have an identity that sec square a minus tan square a is equals to 1, right? We have seen an identity that 1 plus tan square a is equals to sec square a. If you rearrange that, you will get sec square a minus tan square a is equals to 1. So your final answer is 9 into 1, that is 9. So your correct option is option B, right? Okay, second question is 1 plus tan theta in plus sec theta and to 1 plus cot theta minus cosec theta. Now here this either I open the bracket, I multiply 1 with 1, 1 with cot a, cot theta, 1 with cosec theta, and similarly tan theta with all these things and sec theta with all these things and simplify, or else I can convert this tan, sec, everything in terms of sin and cos. Now mostly you will find that it is easy that if you convert your other ratios in terms of sin and cos, right? So you have to concentrate on only two parameters, only two ratios, that is sin and cos, and respective identities or relations. Okay, so I have converted in sin and cos. So this is 1 plus sin theta upon cos theta plus this sec theta is 1 upon cos theta. Now here 1 plus this cot theta is cos upon sin minus cosec is 1 upon sin. Now here it is cos theta, so I multiply this first term also by cos theta, numerator and denominator, so that my denominator is same, and I will write this as cos theta plus sin theta plus 1 whole divided by cos theta. And the second bracket, in the same way I have sin theta plus cos theta minus 1 whole divided by sin theta. Now here in denominator I have sin theta cos theta, and here in numerator if you see it is sin theta plus cos theta plus 1 and sin theta plus cos theta minus 1. So here I can use the identity of a plus b into a minus b. So a plus b into a minus b is a square minus b square. So let us apply that. Here I have cos theta plus sin theta the whole square minus 1 whole divided by sin theta cos theta. Now expand it. So this is cos square plus 2 sin theta cos theta plus sin square minus 1. This cos square theta plus sin square theta is 1. So I replace this cos square plus sin square with 1. Then here it is minus 1. So plus 1 minus 1 I can cancel. And I have only numerator as 2 sin theta cos theta and denominator sin theta cos theta. So they cancel and finally I will get 2 as my answer. So your option C is the correct option. Now this third question, 1 plus tan square A upon 1 plus cot square A. So again I will use the identity that 1 plus tan square A is sec square A, 1 plus cot square A is cosec square A. Now this sec square A I can write as 1 upon cos square A, and this 1 upon cosec square A I can write as sin square A. So this is sin square A upon cos square A. So sin square A upon cos square A is what? Tan square A. So your option D is the correct option, right? Hence the correct option is option D. Now the fifth question is prove the following identities where the angles involved are acute angles for which expressions are defined. Now these proofs we have 8 to 10 proofs that we have to do, and they are very important. So I will cover that in our next lecture. I will stop my lecture here. Thank you.